For most of modern medicine, the idea of bacteria freely living in our bloodstream was akin to finding a raccoon living in your refrigerator. Unsettling, dangerous, and probably an emergency. But times and microbes are changing. As sequencing technologies grow more sensitive and our understanding of microbial life becomes less gut-centric, surprising discoveries keep bubbling up in the most unexpected places. One such surprise is Paracoccus sanguinis, a little-known bacterial species that might just be one of the friendliest gatecrashers in your circulatory system. First identified not in a hospital ward or septic wound, but in samples from healthy individuals, Paracoccus sanguinis belongs to a group of bacteria once considered strictly environmental. Members of the Paracoccus genus are usually found in soil, water, and even industrial wastewater, where they break down nitrates and help clean up toxins. So, what's one doing calmly circulating in human blood? That's the million-dollar question. But early research suggests that P. sanguinis might not be a pathogen at all. In fact, it could be playing a quiet, supportive role in immune regulation and oxidative stress management, possibly even helping to calibrate the body's inflammatory responses. Think of it as a microbial diplomat who's figured out how to rent space in your bloodstream without triggering alarms. How does Paracoccus sanguinis survive there? It appears to have a rather unique toolkit. Unlike pathogenic bacteria that reproduce wildly and provoke immune attacks, P. sanguinis seems to fly under the radar. It has a relatively slow growth rate and expresses low levels of inflammatory surface markers, which helps it avoid being mistaken for a threat by immune cells. Some evidence even suggests that it may interact beneficially with white blood cells, especially macrophages, perhaps modulating their activation in ways that reduce chronic inflammation. That's no small feat, considering the bloodstream is patrolled by some of the most ruthless microbial bouncers in the human body. Even more intriguingly, P. sanguinis may produce bioactive compounds, like small fatty acids or redox-balancing molecules, that influence the systemic environment. While we're still early in understanding exactly what it's making and how, some preliminary data suggest these metabolites might enhance cellular resilience to oxidative stress, a major player in aging and chronic disease. If these findings hold up, P. sanguinis could become one of the first identified blood-dwelling microbes with protective effects, an internal symbiont, not a stowaway. There's even some speculation that P. sanguinis might influence endothelial health. The endothelium, the thin layer of cells lining your blood vessels, is highly sensitive to inflammation, stress, and circulating signals. If P. sanguinis helps dampen immune overactivation or produce nitric oxide precursors, it could indirectly support vascular tone and reduce the risk of atherosclerosis or hypertension. In other words, it might be the microbial equivalent of a vasodilating whisper. Still, let's not get ahead of ourselves. While early findings are promising, Paracoccus sanguinis hasn't yet had its big debut in mainstream clinical journals, and much of what we know is based on small-scale sequencing studies, microbiome surveys, and early metabolic assays. Contamination is always a concern in low biomass environments like blood, and the question of whether P. sanguinis is truly alive and functional, or merely a persistent trace presence, remains open. But even the idea that blood may tolerate or even benefit from the presence of a microbe like P. sanguinis is a radical shift in how we understand our inner ecology. For years, the gut microbiome has gotten all the attention as the body's microbial command center. The skin microbiome got a skincare line. The vaginal microbiome got probiotics. But the blood? It's only just now being invited to the microbial party, and Paracoccus sanguinis may be one of its first surprising guests of honor. If further research confirms its activity and benefits, it could spark an entirely new category of diagnostics and therapeutics, targeting or enhancing friendly blood microbes to improve immune balance, slow aging, or even optimize cardiovascular health. Imagine a probiotic not for your gut, but for your blood. Science fiction?
For now, yes.
But a decade ago, the idea of blood housing any bacteria at all would have been called absurd. So the next time someone tells you your blood is sterile, you might raise an eyebrow and whisper, "But what about Paracoccus sanguinis?" This quirky microbe could one day turn out to be one of the quiet heroes of human health. Or, at the very least, a symbol of how little we truly understand the vast microbial world living not just on us, but within us.